back to the part 2 of Lewis structure and VSEPR, valence shell electron pair repulsion. So in this part 2, we are going to write the Lewis structure and how to calculate the formal charge, okay, or known as FC, and also the exceptions to the octet rule. Okay, so how to draw the Lewis structure? First of all, you need to sketch the skeletal structure of the compound, and first thing is you need to put the least electronegative element in the center. Okay, so the least, you need to identify the least electronegative element in the center. And second one, the second step here, you need to count the total number of valence electron. Okay, so add 1 for each negative charge and subtract 1 for each positive charge. And third one, okay, you need to complete all or you need to complete an octet for all atoms, okay, except the hydrogen. And last but not least, okay, if structure contains too many electrons, okay, you need to form double or triple bonds on central atom as needed. And last but not least, okay, you need to check their formal charge for each atom in the structures. Okay, alright. So number 5 here, formal charge. Okay, so we have the first example. This is nitrogen trifluoride. So for the first step, you need to sketch and you need to determine which one is the least electronegative in order to put it in the center of the structure. So for the nitrogen fluoride, okay, so this is nitrogen, okay. Nitrogen is least, okay, negative, electronegative compared to the fluorine. So nitrogen will be the center atom, okay. And then surrounded by 3 fluorine. This is nitrogen trifluoride, okay. And then after that, this is the first step. Alright, the second step, you need to calculate the valence electron surrounding this structure. Okay, so we have nitrogen here, 5 valence electron, and fluorine we have, okay, so fluorine we have 3. So the valence electron for fluorine is 7 times 3, so 26 electron. Okay, this is the second step. And third step, you need to fill up the electron, okay, octet rule, okay, here surrounding the atoms except for the hydrogen. So we have 26, so we start with the electronegative element. So we have 2, 4, 6, and then another 6 here, right, and another 6 here. Okay, alright. So surrounding the fluorine here, we have 8 electrons, so times 3, okay, 24, 24. And then we have extra of 2 here, okay, extra of 2 here. And guys, okay, remember that nitrogen follow octet rule. So the 2 here must be the lone pair, okay, alright, surrounding the nitrogen, okay. So nitrogen follow octet rule. And then here step, okay, this is the step 3, and then you check the single bond, double bond, and also triple bond here, okay. And you look at this everything, so 26 of this, so this is the structure of nitrogen trifluoride, okay. And then you need to check for the formal charge. So for the formal charge, I will explain to you later in this part, okay. So other than that, another example, we have carbonate ion, okay. Alright, so back to this first, okay. We don't have any charge here, so we don't need to add or subtract 1 or based on the charge, okay. So here, second example, we have carbonate ion. So this is anion, okay, right, CO3 2-, okay. So first thing is you need to draw the skeletal structure. So carbon will be the least electronegative, surrounded by oxygen, 3 oxygen. And then don't forget we have this -2, so you need to draw, okay, here, and then put it as -2. Okay, then second one, alright, you need to calculate the electrons surrounding this structure. So carbon is valence electron is 4, oxygen is 6. Okay, we have 3 times 3, 22, and we have extra 2 charge here. Okay, so we need 2 plus 2. So overall is 24 electrons. Okay, 24 electrons. So, okay guys, alright. So then the third one, you need to fill up the octet, okay, surrounding of the carbon and also oxygen. So if you look at this carbon, okay, carbon follow the octet rule. So usually we rarely see the carbon has lone pair, so you can put it as the double bond here, here or here, okay, and then you fill up the valence electron. Okay, right, so 2, 4, 6, 8, 10, 16, 19, 20, 26. Alright, okay. So, alright. So let's check first. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, it is 24. So this is the Lewis structure for the carbonate ion. Okay, in order for you to determine whether you have the correct Lewis structure or not, you need to be able to calculate the formal charge. Right, so what is an atom's formal charge? Okay, it is actually the difference between number of valence electron in an isolated atom, okay, and the number of electrons assigned to that atom in a Lewis structure. Free atom or isolated atom minus with the non-bonding and also minus half of the bonding electron. So the formula here is, this is the formula for the formal charge. Okay, alright, so and the sum of the formal charges of the atoms in a molecule or ion must equal the charge of the molecule or ion. Okay, so in this example here, we have 2 possible skeletal structure of formaldehyde. Okay, this is the first one, okay, where the carbon and also oxygen, okay, at the center of the structure, and then we have this second skeletal structure where the carbon is the center atom. Okay, so how to determine this formal charge? Okay, let's go to the first skeletal structure of formaldehyde. So here, when you draw the Lewis structure, okay, this is the Lewis structure of first skeletal of formaldehyde, and you need to count or you need to calculate each formal charge of the atoms, okay, that we have in the structure. Okay, so first thing is we have carbon and also oxygen. Okay, so let's calculate the formal charge of the carbon. So the valence electron for carbon in free atom is 4. Okay, this one you need to refer the periodic table, minus the total number of non-bonding electron. Non-bonding here, it is actually refer to the lone pair. How many lone pairs do we have in this structure? So in this carbon, we have 2. So 4 minus 2 minus half of the total number of bonding electrons surrounding this carbon. So how many do we have bond? Okay, the bonds that we have here is 1, 2, 3. Okay, 3 bonds, and 1 bond will give us equal to 2 electrons. So here it is actually 3 times 2. Okay, 1 bond equals to 2 electron, 2 bonds equal to 4 electrons, and if we have triple bond, it is actually equal to 6 bond. Okay, 6 electrons. Okay, so 4 minus 2 minus half, half times 6. Okay, we will have the carbon here as -1. Okay, and then other than carbon, we have oxygen here. The valence electron for oxygen is 6, okay, minus the lone pair, okay, non-bonding electrons, okay, lone pair we have 2 here, minus half, okay, times 6, because we have 3 bonds surrounding the oxygen. This is +1. So this charge is -1 and this charge is +1. Alright, so the total overall, okay, the total number of this formal charge in this first skeletal structure is 0. -1 plus 1. Okay, so what if, okay, if we have this kind of skeletal structure? Am I missed this one? Okay, alright guys, so why don't you calculate, okay, the formal charge for this structure? Alright, so you need to identify which one is the most stable Lewis structure, okay, because we have 2 possible skeletal structure for formaldehyde. Alright, and then for the formal charge and also Lewis acid, especially for the neutral molecules, Lewis structure in which there is no formal charges is preferable to one in which formal charges are present. Second one, okay, Lewis structures with large formal charges are less plausible or less preferable than those with small formal charges. The best one is 0, okay, neutral, 0. And then among Lewis structures having similar distribution of formal charges, the most plausible structure is the one in which negative formal charges are placed on the more electronegative atom. Okay, so you need to identify these 3 factors, okay, in order to determine the most stable Lewis structure. So here, which is the most likely Lewis structure for formaldehyde? The answer is this one. Okay, why? Because the formal charge for carbon and also oxygen here are 0. Okay, right, compared to the one here. Okay, carbon is -1 while for the oxygen is +1. Okay, based on these 3, okay, the best one for the formaldehyde is structure number 2. And other than how to draw the Lewis structure, we go to the resonance structure. This is where we have one of 2 or more Lewis structures for a single molecule that cannot be represented accurately by only one Lewis structure. The easiest example for this one is benzene. Okay, this is how we draw the benzene, right? And this benzene also equal to this structure. Okay, or this one. Okay, or this structure. Okay, so 3 of these are acceptable. Okay, why? Because we have movement of electrons surrounding the benzene. Okay, or we call it as resonance. Okay, another example, we have ozone. Okay, this is O3. Alright, you can draw the Lewis structure of O3 like this or like this, as long as the formal charge are correct. Okay, and then alright, other than that, the question here, what are the resonance structures of the carbonate ion? Okay, this is CO3 Okay, so it can be like this, or it can be like like this, okay, because we have -2. Okay, this is supposed to be -2. Okay, one negative here and another one is here, so this overall structure equals to -2. Okay, and then another one negative here and negative here, so this is -2. Okay, and another one, it can be like this. Okay, so one negative here and negative here, this is -2. So for the carbonate ion, okay, we have 3 resonance structures. Okay, then we go to the exceptions to the octet rule. Okay, first thing is the incomplete octet. Usually these focus on beryllium and also boron. Okay, anything with beryllium and boron. Why? Okay, they do not follow the octet rule. Okay, alright, so they actually follow the incomplete octet. Okay, so for beryllium, from this Lewis structure, we can see only 2 bonds, okay, surrounding the beryllium, and then other than that we have boron trifluoride. Okay, so surrounding the boron here we have 3 bonds, okay, where the boron is connected to the fluorine here. So also incomplete, so means less than 8 electrons surrounding the central atom. Okay, so yeah guys, especially for the beryllium and also boron. Other than that, the exceptions to the octet rule, we have odd electron molecules. Okay, the easiest example is nitric oxide or nitrogen monoxide. Okay, so where the nitrogen here, okay, instead of 4 we have 3, okay, electrons surrounding the nitrogen. Okay, and then last but not least, we have the third one, the expanded octet. Okay, expand means more than 8 electrons surrounding the central atom. So example here we have sulfur hexafluoride. Okay, sulfur hexafluoride, so we have 6 bonds, okay, or 12 electrons surrounding the sulfur. Okay, other than that, other than sulfur, we usually can find example using the phosphorus. Okay, alright, yeah, sulfur and phosphorus. Okay, so okay, then you need to calculate the electrons surrounding the sulfur. That's all for today in this part 2. So after this, I hope you guys can, or you guys are able to draw the Lewis structure and how to calculate, and you guys are able to calculate the formal charge and also the exceptions to the octet rule, where we have the 3 exceptions. First one is the incomplete octet rule, odd number electron molecules, and also the expanded octet. And then, so guys, I hope you guys have a good day, and I'll see you guys in part 3. So bye.